My name is Vlad, and this is Matt Dean and Matt Roper, and we are here to talk to you about the art to being more technical. I'd like to get a sense of who you are first. So by show of hands, how many of you are purely on the artistic side of things? Okay, a few of you. How many of you are both art and technical side? Why are you here? And how many of you are purely technical? Don't ask us any questions. Good, thank you. So you might ask yourselves, well, why do you want to be more technical? Especially if you are a pure artist, you might just say, I love art. And all three of us are coming from a technical artist background, but we were originally artists. So hopefully we'll try to share a little bit more information of the benefits of picking up some technical skills here and there. One of the main reasons you want to be technical is because your colleagues will view you as a wizard, all right? The extent that you can become more employable, the extent to which you can actually work on your own project further is really, really outweighing sort of the scary first step of dropping the art tools and trying to pick up some scripting, programming, and so forth. Now, when we talk about being a technical artist, that term is being thrown around a lot, and that can mean a lot of different things. The three of us would really like to focus on these three areas. I will talk to you a little bit about shaders, Matt Dean will talk to you about color space, and Matt Roper will talk to you about scripting with C#. Now, clearly, in 50 minutes, we won't make you be proficient in this, and to be fair, neither are we. So the point of this presentation is not necessarily to give you a tutorial, but really to demystify some of the scarier first steps into approaching these fields, hopefully make it a little bit more easy to get into, and then provide you some links at the end that will help you get started if you feel that this is something you would like to explore. So I have the pleasure of starting this talk with shaders. And when people hear shaders, they usually think that it's something very scary and exciting at the same time. And there are many, many different kinds of shaders out there that can make this very daunting area to approach. I will talk about probably the most common ones you will encounter and ones that are used within Unity a lot, the vertex fragment shaders. Now, on the art side of things, you're familiar with the structure. You will have some kind of model, which will have, of course, vertices, UVs, vertex color. You put some material in it in Unity, and then you can put textures to it, tweak some properties, and at the end of the day, that material is using some kind of shader from the list there, and it's doing some kind of magic. Well, the magic is roughly like this. You have some kind of input from the mesh. We spoke about the vertex position, vertex colors, UVs, normals, tangents, and then you have these two functions, a vertex function that's doing per vertex calculations, and a fragment function doing per fragment calculations. Now, if I leave it at this, most of you will just walk out here, so we kind of have to address these two. When I started with shaders, I had no idea what exactly they were doing. So, a vertex shader will basically execute once for each vert of your 3D model. So in this amazing case, if you have modeled a triangle and you want to bring that into the computer, the vertex shader will transfer that into screen space and put it on the screen. And then to feed some information to the fragment shader, which in turn will run for each segment of that piece and populate it with this information. Now, fragments are potential pixels. So they're not quite pixels yet, because there's one more step, and that is, if part of our amazing triangle is obscured, we don't really need to render that. So we'll drop those fragments, and we'll just render these as pixels. So if you open a shader, you will see something like this, and you will close the shader right away and decide this was a bad idea. And part of the reason for that is spooky language. Shaders have a very, very unique language that goes to them, it's very specific to them, and to make things more confusing, in this case it's a combination between Unity-specific shader lab code and CG, which stands for C for graphics. So some of the things you can sort of get an idea what they're about, and others are completely scary. So the good news is, a lot of this scary, spooky language is purely arbitrary. You'll probably see things named in this particular format, but you can really name them anything, and this will still run. And the good thing about that is, once you see different shaders written by different people, and you all of a sudden go like, I have no idea what's going on, maybe this will help you a little bit to understand that this is really what somebody decided is a good naming convention. So that's the good news. The bad news is, a lot of the spooky language is just that, spooky language, and you do have to learn it. The actual anatomy of a shader is broken into these segments. You will have the actual shader with some kind of name in it, and that's what you actually see in Unity when you have your material in trying to assign a shader. Within that, you have properties. You might not necessarily directly work with properties as such, but everything you put here, unless specified otherwise, is exposed in the Unity inspector. So whenever you see something called color, anything that's texture, this is where you put this information, and this is how Unity communicates with the shader code. And then you have a sub-shader where really all the meat and potatoes of the shader code goes. So we will start a little bit with properties. This is the format. You will have some kind of name for the variable, something you'd like to display in the inspector, what type it is, and what value. So in this case, if we have a color property, we name it myAwesomeColor, it's of type color, and then we set it as red. This is what you see in the Unity inspector. And again, this is not something to follow along. This is hopefully something you guys can open a shader at the end of this and be like, I think I know what's going on. And you can put a lot of different things in the properties block. Color, texture, some kind of numbers, ranges, cube maps, vectors, I mean, you name it. And this is sort of what it will look like if you put these particular values in your shader and you load it up in Unity. So this was the properties block. Things are getting a little bit more intense here. The sub-shader block is being run each time for any particular graphics hardware. We lost one gentleman. Hopefully the rest of you will stick around. The first part of the shader, the sub-shader, will contain also a pass, which is being called each time you want to render that particular mesh. So most of the time, for very simple materials, very simple shaders, you just have one pass, and you just say, grab this, put it in screen space, and make it red. But often, if you guys know, for example, the cartoony effect with the toon outline, you actually have to have two passes where you first render the whole thing with the outline color, then a smaller pass that actually renders your model in the middle with whatever texture you want to have on it. So passes will be executed each time you need them to for more complicated shaders. And also, in the sub-shader part, you will have some Unity-specific language that you might be able to control things such as, do you want your material to be double-sided? Do you want to blend it in a certain way, especially for like additive materials, things like special effects, and whether you want to render it at a particular time as opposed to other objects. In the pass function is where the actual CG code lies. And as I mentioned, CG stands for C for graphics. And basically, all the codes in all our shaders would be sandwiched between the CG program and NCG. And between those, we're no longer using Unity's shader lab, we are using the CG language. Inside of it, you will have things like the vert and the frag function we discussed before, and you might very often see this include file, unitycg.cginc, which is sometimes optional, but it can allow you to really call a lot of things without having to write them manually. So it has a lot of presets and data that you don't have to declare on your own. So we will focus on the actual functioning of the shaders within vert and frag. I explained briefly before what's the gist of them, but this is how it actually looks. I mentioned a little bit about the naming convention, so let's just decide what these things actually do. App data is a place where you store the information from the mesh. V2F is the place where you're transferring that data within the vert function and saving it out to use later. This is the place where you actually are doing all the conversion, and this is the place where you get all the converted rasterized data and you're doing the whole pixel conversion. So since this is confusing language, let's just call them what they really are. And you will see this most often. Usually they are called like this, but really vertex input, vertex output, and then we have the vert function and the frag function. So what happens? We get the information from our mesh, and it's being accessed to the vert input function. And as I mentioned, you can call these anything. That thing is being loaded in your vertex part of the shader, and it's doing the calculation where it's transferring it from the local object space into the screen space. So for example, if your model is here, but in the game it's like way back there, it will do the calculation to set it in the appropriate angle, size, and position. Once you're doing all of this, it will save where the new position is, and then the frag function will grab that and say, okay, in this case, I'm just going to fill it with a white color. Remember how we spoke before about properties? The properties, to actually communicate with the rest of the shader, because they're part of a different language, we literally just need this little thing. So to get our color from up there to down there, within the CG function, you just have to actually include the variable name, in this case, color. And that is really it for shaders. You'll be able to create your own, or even better, just customize what we have. So as a first step, my recommendation is just create a shader. If you just go in Unity, create shader, and you can do one of the simpler shaders, such as the unlit shader. Once you create that, you just create an asset, just like any other asset you guys have used already. You double-click that, you can get the shader name, and all the shader code, of course. This is the default name for the unlit shader. And you can open it, you can do all the changes that you want, just try little things, tweaking it here and there. And once you do that, you can literally just assign it to a material, drag it on your object, and see what it does. So shaders can be quite scary, but it can also be quite exciting. Hopefully this will be a nice little introduction to what they can do. The power of them is really unlimited, but especially if you're just starting up, don't feel like you have to actually have studied any of this. It is really approachable once you demystify some of the scary things behind that. I'm saying this from a purely art background. The last math class I took was in college. It was called Math for Artists, and I'm not making this up. So it's quite approachable. I hope you guys will give it a shot. I will introduce next my colleague Matt Dean, who will talk to you about a very different area, color space.
Hello. Thanks, Vlad. Right, so I'm going to talk to you about color space. This will be interesting. So, let's talk about color space. A color space is a range of colors that can be created by the primary colors of pigment, and these colors then define them. We're not interested in that, right? This is actually gamut, and we don't care. So, instead of that, what we are interested in is color space in the context of Unity. You can find the color space selection under player settings. It has two options, linear and gamma. And color space in Unity is really the working space in which textures, red, and lighting is calculated. So, hopefully by the end of this short presentation, you're not only going to understand the difference between linear and gamma color spaces, and the limitations of each, but also be able to make an informed decision as to which you should choose for your game and what the impacts are going to be. So before we do that, we need a brief bit of history. Sorry about this. So in 1869, Johann Hittorf discovered that when a high voltage was applied between two electrodes in a glass tube, some unknown rays were emitted. When these were measured, these rays were found to be made up of particles smaller than atoms. They were electrons, and this was actually the first discovery of subatomic particles. And hopefully you all remember CRT monitors. It doesn't appear to be anyone so young in this crowd that you wouldn't.
Except for all the ladies.
Yeah, okay. And yeah, that's how they work, right? So by firing electrons from components called electron guns at a phosphorescent screen, the electrons are masked by the screen to block out the ones that aren't wanted, and this is how we produce an image on a CRT monitor. So interestingly, the light intensity of the output of a CRT varies non-linearly with the voltage of the electron gun. Because of this, images that are sent to a monitor must have the inverse applied to them, so that when the picture is delivered to the viewer, it has the intended luminance. This is what we call gamma correction. Okay, so almost no one uses CRT monitors anymore, right? It's 2016. So why do we still use gamma correction? So interestingly, it turns out that the human eye follows almost exactly the same curve as the gamma function, with the most sensitivity to mid-grays. It's very unsensitive to highlights and very deep darks. And because of this, if we don't gamma encode an image, then we allocate too much bandwidth to the high and low areas, and we don't get enough bandwidth in the mid-grays, and you are going to notice this at 8 bits per channel. If we were to do it linear, then you would need, it's roughly 11 bits per channel, which is somewhat awkward. So this is why we still do it. So anyway, what does this all mean? Well, it means that no color that you see on your screen is the color that it actually is.
What?
Exactly. Images are saved in gamma space. So on your hard drive, this image actually looks like this. You never see it like this, but that's the way it is. When the monitor's gamma is applied to it, it's the inverse of gamma correction function, and it looks correct, like this. So let's get back to Unity and look at something more practical, right? As I said before, Unity has two color spaces, linear space and gamma space. And the difference between the two is pretty simple, but the impact is massive. So let's take a look at it. So in gamma space, textures are read from your hard drive in gamma space, meaning that gamma correction is currently applied to it. Then the lighting model is applied in gamma space, and then finally your monitor applies its gamma and it gives you the final image. Now, because the lighting is calculated in gamma space, it's adjusted by the curve of the monitor's gamma function, and it's incorrect. Whereas in linear space, the image is again read from the hard drive in gamma space, and then we convert it to what we call linear space, which is the perceived color space, and then the lighting is applied to it in the perceived color space. Then we apply the gamma correction back to it to put it back to gamma space, and then finally the monitor's gamma is reapplied to it, and we ended up with the intended luminance. Okay, so at this point you're probably thinking, like, sure, these look different, but one doesn't necessarily look better than the other. And you're right. Linear doesn't necessarily look better, but it looks correct. Okay, so like, let's compare these things to reality, all right? Here you can see a sphere in reality, some volleyball, I guess, and in gamma space and linear space. Sorry, I didn't have a volleyball model to do this with. I just used the Earth. It's good enough, right? As you can see, in reality, the shadow has a very harsh fall-off. And you can see this is matched in linear space, and it really is not matched in gamma space. The fall-off is A, inconsistent, it's too broad, and it's not the same. Okay, right, fine. On a ball, fine. But let's see how much this can actually affect your artwork, because that's what we really care about, right? So here's Dr. Charles. We all love Dr. Charles. I've put up some renders of him in linear space and gamma space, as well as the albedo texture for his clothes. And just for reference, this model is lit with a single directional light, which is pure white. There is some ambient, which is in pure white also. There is no GI of any kind. And we are interested in this section here. So if I enlarge that, straight away you can see how obviously wrong the hue of this orange area is here in gamma space. If we compare it to the texture, it's pretty obvious, although it's a lot less orange on the projector than it is on this screen here, but yeah, the difference is still pretty obvious. So I'm going to show you that I've added an adjustment layer in Photoshop, and we can see straight away that the hue of the orange is about 15 degrees out, simply because of the way the lighting calculations were done. Because the color of the diffuse is used in the lighting calculations, and it's been distorted by the gamma curve, we end up with a hue shift. And I think, as at least all of the artists in the audience can agree, that this is completely unacceptable. Okay, so if we get back to Charles, here again we have gamma and linear. And what I'm going to do this time is I'm going to increase the light intensity. At the moment we're at directional light with an intensity of 1. And already you can see the difference in the way the lighting is being applied to his face. So if I increase it a little bit to 1.5, you can already see that the way that the model gets lighter in gamma space is completely inconsistent. It's nonlinear. And the brighter areas of his brow and nose are already completely white and washed out. And I'm pretty sure you can guess where this is going to go if I increase it a little bit more. Yeah. At this point, the linear image is also starting to get a little bit washed out, and this is probably why you shouldn't have a directional light of an intensity of 2 straight onto a character's face, but that's not really the point. Yeah, the gamma space image is completely washed out, and yeah, this is just what you're going to get with the way the lighting calculations are done. So let's look at the pros and cons of each working space, because there are pros and cons to both. The main takeaways here is that the linear workflow is correct. Therefore, if you're using physically based shading, physically based materials, if you're working in gamma space, essentially what you're doing is negating all of the advantages of physically based rendering. The fact that it's energy conservant goes out the window. Whereas in linear space, because everything is lit correctly, it is physically based, and you are going to get the results that you expect. However, the main con of linear space right now is that we do not currently support it on mobile platforms. We support it on console platforms, on PC, on Mac standalone. I believe we support it on WebGL, although I'm not 100% sure on that. So yeah, there is a slight con there. So yes, that was my presentation on color space. Yeah, hopefully it was at least slightly interesting. If you're making a non-mobile game and you're working in gamma space, or maybe you don't know which color space you're working in, I would really encourage you, when you get into a position to do so, switch to linear, play with your lights so that you get the values that you want again, and you may find that the result that you get is going to be a lot better. Your lighting is going to be more consistent between levels, for example. You may really like the result. So I'm going to hand you over to my colleague Matt Roper for a talk about C# scripting.
There we go. Awesome. Hi, everyone. So my part of the presentation is going to be covering how it's possible to make your life easier by using C# as an artist. This is mainly aimed at tools and to inspire everyone who is an artist to hopefully take it up and make their lives easier with it. So I'm going to get started here. It's really not as hard as you may think. At first, it is very daunting, but for you, those of you who went to training day yesterday, hopefully you did learn something from it and didn't find it as daunting as it really is. And even myself, after programming for many, many years, still do get stuck on stuff like that. So I do myself find it daunting, but it really isn't that hard. You'll gain the ability to make tools that will make your life easier. This isn't just limited to Unity as well. It carries over to applications like Maya or Max as well. And there's amazing resources available all over the web, Unity, Microsoft, Stack Overflow, YouTube, literally everywhere. So those of you who have worked as an environment artist or in literally most jobs ever may have experienced this. And if you do become more technical in your workflow, then you probably will find it a lot more easier to increase your proficiency, maybe even twice or threefold if you're that good. So I like to believe that programming unlocks your creative freedom. And what I mean by this is that you can literally start to create things that not a single programmer or artist could do on their own. At least most of them, I can honestly say I've never met somebody that could make something like this on their own. And thank you for Oscar if you're here for letting me use this. You'll also find the ability to create the games on your own, often more employable. I'm sure that doesn't apply to everyone. I'm sure some of you are great artists and get on very well like that. And it gives you a better insight into your field, for example, how 3D models are structured, how they interact with stuff such as color space, or even with shaders. So what I want to show you today is a common and easy thing that you can avoid that I often come across when I'm playing games, and I often find it's something that could be very easily avoided, but makes the artist they could be lazy or didn't check. And here's a few examples of objects that are floating in the scene. And it really is something that only takes a few seconds to do or to look for, but often does slip through the cracks and has been persistent in many games, such as World of Warcraft here, for many years. So what am I going to show you? I'm actually going to stray away from the type of presentation my colleague's done here, and I'm going to write a quick script in a moment to hopefully inspire you to show that you can write scripts that aren't necessarily written in the best way that will give you peace of mind and help you out. So what is it going to do? It's going to check the distance from all the scene objects to the ground or any objects below it. It's going to be runnable in edit mode and no need to play. You just simply tick a button to place objects or check their distances, and avoid releasing the product with poor placement, at least in my eyes. So what it's going to do, here's an example, as a rock. Simply it's going to draw a raycast from the rock down to the floor. And for those of you who don't know what raycasting is, it's if you've ever seen a builder with the little laser pins that they shoot at the walls, and it tells you the distance, it's literally one of those. So we'll get the distance there. So I'm going to go ahead and switch into Unity here. Bear with me a moment as I need to change my screen alignment around. Use a mouse. And duplicate. Yes, great. So here we are in Unity, and I've already set up a very simple scene. And I've worked on this for months, and I hope that none of my cubes are not placed on the floor. And so what we're going to do is essentially write a really quick script. There's no more than 50 lines that will check these objects and give you an option to place it. And this will be without an editor script. And the thing that I want you to take away from this is not a lesson of how I'm going to do this, but to show you that it's very quick to do, and you don't need to do it in a way that others may find efficient, as it's only ever going to be run once and possibly deleted from the project afterwards. So I've already created a script, and we're going to get rid of this string here because we no longer need that. And we're going to add back the using system.collections. So this is a default script that you'd get in Unity after opening it. And for those of you that don't know any scripting, I just want to run over a few basic things here with you. So a class can be seen simply as a box, a shoe box, and anything inside of it could be a pair of shoes which contain different functions, like Velcro if you need Velcro, or laces, and these can be your Velcro and your laces. And for this demonstration, we won't need the start function. So I'm going to start writing here. The first thing we need to do is check for any objects in the scene with a certain tag name. So any objects with this tag. And we're going to simply look for those. So the first thing we're going to do, which all of you, if you do know about update, will think I'm crazy for doing it, as it checks per frame, or near per frame. It will run per frame, which will set my laptop on fire. Not really, but. So we need to eventually avoid that, so bear with me if you think I'm crazy. So the first thing we're going to do is write a for each loop, and we're going to go for game object, go in game objects, dot find objects with tag, and we're going to pass it the tag name. And whoever made the noise about that, as I said, is more aimed at how you can write a script in a bad way, and it doesn't matter. You don't need to be afraid about the meta and formatting, because it's for yourself and to make you more efficient. Anyway, so what we're going to do is once we've found these objects, this for each is going to return me all the objects in the scene that has this tag name. And we're going to need a raycast for each one. Raycast hit. And we're going to call that ray. And what we're going to do from there is use this raycast now. So we're going to do if physics, not material, dot raycast. And first thing we need to do is point from where the ray will start. So in this case, we're going to pass it go.transform.position. We need to give it a direction. In this case, we're going to use vector3.down. And vector3.whatever is very handy, because in this case, vector3.down can shoot from any game object of any rotation, and it will always fire down. There's many presets that you can use, such as up, left, right, forwards. And we need to then pass it out the ray, which we defined above here. So we say out ray. Sorry, ray. Okay. So now what do we have is we look for every game object in the scene that has the tag. We define a raycast hit, and we use the raycast hit, and now we just need to simply check the distance that we want. So if ray.distance is greater than 1, then we need to do something with this mesh or object. So the next thing I'm going to do is create a quick custom class, add another class at the top here. And we're going to call this object information, or info, sorry. And it's not going to inherit from mono behavior, because we don't, well, it's being attached to the object, but we'll be attached with the script below, which already inherits from monitor behavior. And we're simply just going to say public game object, and we're going to call this G object. And we also need a public string of logged info. And so we're going to attach this to every game object that gets found, so we can log some information about it. So the next thing we need to do now is actually store those in a list. So as we're not using any enumerators, we can actually change this to system.generic. This way we can now create a list. So public list of type game object. Actually, no, I lied. Object information. And we're going to call this floating objects. And we're going to just create the list there. So any objects which are found in the list to be floating will now be stored within this list. Now we can log the information about it. So we're going to say object info, and that's going to be called caught object equals new object information. From here, we can now go to caught object dot g object equals go, and caught object dot logged information equals object is plus array dot distance plus off the ground. So forgive me if you don't like formatting strings this way. It's quick and efficient. I've often been told off about it, but I do like it. So, and yeah, so what we're going to do is, if we go back to the scene here, one more thing, public bool, update, did. So when I said that we're putting this in update, the reason is because eventually we'll want to add it to the editor, and we want to be able to click the update a boolean, which will run through and grab all the objects, but we don't want to keep on running. So we always need to make sure that we click it. And I've put insert, I don't want that. Updated. Sorry. And finally, before we run it, we want to make sure that we do floating objects dot clear. And if you don't understand this at this point, please bear with me, as it will become a lot more clear in the editor when I run it. So we're going to go in the editor here, and hopefully that we have no errors. Ones that we care about, at least. And we're going to drag and drop this onto here. So we need to make sure that we set up the scene objects tag, scene objects. And we're going to copy that, and we need to make sure that we have a tag for this object as well. So we're going to create a new tag. And tags are great ways to tag objects in the scene which need certain specifications or just need to be found easy. We could look for all the meshes, mesh renderers in the game, but in the scene, but that would obviously not yield the results we wish to get. So we need to make sure our objects are ticked. Now, if I click on the place master here and hit play at this part and hit update, then nothing's going to happen. And that's the reason, because we need to expose the list to the editor first. So, because Unity's can't read, Unity's inspector can't show you lists unless you serialize it first. So I need to make sure it's system.serializable. And now the list should pop up. There we go. And when we hit play and hit updated, nothing is going to happen again. And that's because we're not adding it to the list we just created. Sorry about that. So floating objects dot add, and we're going to add the core object. And we're also going to make sure that this return goes false after running, so that it doesn't keep running. So updated equals true. And given that I would have had more time, yes, I would write an editor script for this, and I wouldn't usually do it this way, but the point is that as I'm doing it for myself, for peace of mind for myself, it doesn't matter. So we now have the objects which are found floating off the floor here, and we're able to see how far off the floor they are, and we're able to click them and see them in the editor on the left here, which allows us to reveal them. And we can choose to do something about them should we want to. but in this case, I'm lazy and I want to place them on the floor automatically. So we're going to add a second bool of public bool placed. And we're just going to simply check here if we should place them or not. So if placed, and we're just going to do vector3, and we're going to call this new pos equals new vector3 of ray.pos point.x, ray.point.y, and ray.point.z. Now you're probably wondering, why do I need to store the 3 positions into a new vector3? That's because the objects in the scene have a pivot point of halfway through a mesh, and if we simply place them to the floor, then they're going to be halfway in the floor, which we don't want. So we need to make sure that we remove half of the mesh's offset from the Y position. So this is going to be plus go.getComponent renderer .bounds .size .y/do. Now what this does is it simply grabs the height of the mesh, divides it in 2, and this will offset it by the mesh's pivot point. And this could go a bit funky if you do have lots of meshes with funky pivot points, but what you would do instead is put it fully negative into the floor and then offset by its whole position instead. But in this case, this works okay. And we're going to do go.transform.position equals new pos, not new vector3. And when we hit play and we hit placed, the object's now placed on the floor. And we know that all of these are on the floor now, because if I reset this, it will clear the list completely, and we know that all the objects are on the floor and everything's fine and we're not going to get fired. But if you know Unity, you know that as soon as I hit play, everything's going to revert back to the state that it was before I played. So we're simply going to add a execute in edit mode. And this will allow us to do this in the editor with the script right here with no problems. So you notice it's grabbed all the list here while I'm playing, and I can now choose to place if I want to, and update. And now all of my objects are safely on the floor, and I can save the scene. And let's say it's just a quick 50-line script to demonstrate that you don't need to write in a comprehensive or a way that is accepted as a meta. You can write in a way that's comfortable to yourself, because it is literally for yourself and for peace of mind. But it is, as I say, it isn't limited here. You can write tools in Maya and Max that will help you do all sorts of funky magic, or even as I showed earlier in the presentation with the towers, all of this stuff comes from working with tools. So we head back to PowerPoint now. And that was C#. And that's all for me.
So we have can I get a, thank you. So we've provided you a few resources here, both from Unity official training, documentation, and whatnot. The slides will be available. We do recommend you to either, as you do take pictures, unless taking pictures of us, but do visit them. They're great resources to get started in these areas or explore them further.